Okay, so this question here, shown below is the graph of the function. So function x is equal to x squared minus 3x minus 4, and it's in the domain minus 2 all the way up to plus 5. So in other words, the input values go from minus 2 all the way up to plus 5. We can see here it's a quadratic because it has that characteristic shape of a quadratic, and it's the number or the sign that's in front of the x here, in front of this x, is positive, so therefore you have this characteristic smiley face, if you like. So what you're being asked to do is use the graph shown to write down so the values of x for which function x is equal to 0. So again, remember, it's just really important to remember that function x, another name or another way that you can, instead of writing function x, you can just call it y. So what this is saying is the values of x when y is equal to 0. So when y is equal to 0, and x is going to have two values. Okay, so x is equal to and x is equal to. So basically what you can do is where is y equal to 0? Well, it's along this, so y is equal to 0 is here, so it's all the way along here. So where are the values for when y is equal to 0? So you have this one here, and then you have this one here. So y is going to be equal to minus 1. That's one, or sorry, x will be equal to minus 1, and x will also be equal to 4. So they're the two values when function x is equal to 0 or y is equal to 0. Okay, so that's the answer to this first question. So that's part 1. And these are the roots of this quadratic function. So find the values of x for when function x is equal to 6. Okay, so when function x, so that's function x is equal to 0. So this one will be, so when function x is equal to 6. Or another way of saying it is when y is equal to 6. And again, we're going to have two values. So x is equal to and x is equal to. So again, what we're asking is when y is equal to 6, what's the values for x? So again, we can just draw, we can use our ruler. So we can use a ruler and we can just draw a line across. So when y is equal to 6, sorry, when y is equal to minus 6, should I say? So this is minus 6 down here. So what we can do is we can just line up a ruler like that, and we can draw our line across like this. And wherever it cuts the x-axis, that's where y is. That's the value for x. So for example, we have this value here, which is 1. Okay, so we draw our line. So it cuts the axis here, and it cuts the axis here. So then we just read off the x values. So x is equal to 1, and x is equal to 2. So that's the second one. So the third one then, the values of x when function x is equal to minus 4. So then this is part 3. So again, we're saying when function x is equal to minus 4, okay, another way of saying it is when y is equal to minus 4, what are the values for x? And again, we'll have two values, so x is equal to and x is equal to. So again, we do exactly the same thing. We draw our line, so there's minus, so minus 4 is there. So this is minus 4, and we want to draw our line across like this. And wherever it cuts the x-axis, so wherever it's cutting the graph, so for example, it cuts it here, okay, at that value x is 0. So if x is equal to 0, and then it also cuts the graph at this point here. And at that point, x is equal to 3. Okay, so that's that one. The next one is find the value of function 2. Okay, so now we're kind of changing tact and we're looking at what's the value for y. So we're saying here, find the value of function 2. So function 2 is equal to what? Okay, so another name for this number in here is x. So when x is equal to 2, what's y equal to? So that's what this question is asking you for. So if we have a look here, we just wrote about some of this stuff just so that can see the graph a little bit better. I'll just change the color. So for example, when x is equal to 2, x is equal to 2 here at this point. So we want to draw our line down. Okay, it cuts the graph here, and then we want to draw our line across. So when x is equal to 2, y is equal to minus 6. Or we could say function 2 is equal to minus 6. So that's that one. The next one is question 4, and I'll put that, or question 5, put that up here. So what's the value for a function a half? So again, what we're saying, when x is equal to a half, what's y equal to? So if we have a look here, so we can see here that two of these boxes is like 1 unit. So therefore a half is going to be here. So that's equal to a half. And what we want to do is we want to find out when x is a half, what's y equal to. So we draw our line down. Okay, cuts the axis here, and we draw our line across. So x is equal to minus, or y is equal to minus 5. Y is equal to minus 5. So therefore, when x is a half, y is equal to minus 5. So that's that one. The last one then, or no, sorry, the second last one, should I say, is this guy here. So the coordinates of the minimum point of the curve. Okay, so the minimum point is going to be about here. So that's the minimum points. Now remember, a coordinate is going to have an x value and it's going to have a y value. So what's the coordinates here? So x is, let's say, minus 6. It's roughly minus 6. Or not, sorry. X is roughly 1.5. Okay, so it's 1.5. So x is 1.5. And y is going to be equal to 6. Let's say roughly minus 6 minus 6.1. So that's your x and y, so it's that minimum point here. Okay, so you get your minimum point and you draw your line up. This will give you the x coordinate, and then you draw your line across, and then this will give you the y coordinate. So this is the y-axis and this is the x-axis. So that was that one. And then the last one is, what's the minimum value for function x? So the minimum value for function x, so the minimum, so another way to say that is, what's the minimum, the smallest value for function x, or function x is just y, and the minimum value for y is going to be minus, so let's say it'll be this guy here, so minus 6.1. So minus 6.1. And you just read that off the graph down here. Okay, so that's that question. So hopefully that makes sense and hopefully this helps.